Alrighty, this video is going to work through the double angle, half angle, and sum difference formula worksheet, just so you can get a good idea of how these things work. And you can see a lot of repetition. So this says that sine alpha plus beta. You're supposed to evaluate this using the different identities, and you're supposed to give exact answers. So I don't really want to find out what alpha and beta is. I just want to be able to evaluate them. So if you look at the trig identity, you can recognize that this is the same thing as sine of alpha cosine of beta plus cosine of alpha sine of beta. Same exact thing. That's what the identity says. And of course, we know that sine alpha is 3/5. And alpha is in the second quadrant, so we know that this is 3/5. But we don't know what cosine of beta is, but we have a tangent of beta over here, okay? So what we're going to do is we're going to draw both a triangle with alpha in it and a different triangle with beta in it, because these would be two different triangles, right? And knowing that sine of alpha is 3/5, that would mean that this side would have to be 3 and that side would have to be 5, or some ratio of those, which would force this one to be some multiple 4, because of the Pythagorean theorem. Likewise with the beta, with tangent, if this is 5 and that's 12, then if you use the Pythagorean theorem, you find out that that's 13. Now keep in mind that this is in the second quadrant and beta is in the first quadrant. So then when I come back to here and I want to fill in a cosine of beta, I just look at that triangle. Oh, cosine is adjacent over adjacent over hypotenuse, so that would have to be 12 over 13. And then this asks for cosine alpha, so I go to alpha triangle. Now keep in mind that alpha is in the second quadrant, so I know that cosine is negative there, so I'll put a negative right to begin with. And then cosine is adjacent over hypotenuse, so that would be 4/5. And then sine of beta, go over to the beta triangle. Sine is opposite over hypotenuse, so that would be 5 over 13. And of course, that's the first quadrant, so it's positive. So then we should just simplify this. You're going to get 36 over 65 plus a negative 20 over 65. And of course, that gives me 16 over 65. Okay? And cosine of beta plus alpha is going to be something similar to that. If I look at the trig sheet, the trig identity sheet, I see that that's the same thing as cosine of beta times the cosine of alpha minus the sine of beta and the sine of alpha. And notice the order matters here because alpha and beta are two different triangles, so we need to put those in the right order. So once again, I need to go to the triangles. Oops, why aren't you moving? There you go. So cosine of beta is, as we said, 12/13. 12/13. Cosine of alpha is negative 4/5, because we already saw that. Sine of beta is 5/13. And sine of alpha is 3/5. We multiply those out, we get negative 48 over 65 minus 15 over 65. And that's negative 63. Yeah, negative 63 over 65. This one is kind of a unique one because it's not it doesn't look like the formula on the left side, but it does look like the formula on the right side of the formula. In other words, if you look at the sine difference formula, where it says sine alpha minus beta, you can see the other side of that looks like this. So by looking at that formula, I can figure out that, oh, this is like the alpha and that's like the beta. You see that? So that means I could rewrite this as sine of alpha minus beta. Right? But of course, alpha is pi over 12, and beta is 7 pi over 12. So then what I'm really doing here is taking the sine of negative 6 pi over 12, which of course is negative pi over 2. And sine of negative pi over 2 is negative 1. So here's another fun one here, sine of 75 degrees. You really have two options here. You could think of this as sine of 150 over 2, and then use a half angle formula. Or you could think of it as sine of, say, 45 plus 30. And you may be thinking in your head right now, could I have done sine of 30 plus 45? Sure. Yeah, you could have. That would have worked. So if we do this one, that means this is going to be equal to, if I grab the half angle formula, now my theta in this case is 150, right? So I'm going to do plus or minus the square root of 1 minus cosine of 150 over 2. Well, is it plus or minus? Well, sine of 75 we know has got to be positive, right? Because that's in the first quadrant, and sine of anything in the first quadrant is positive. So I can forget about the plus or minus signs, and I just do this. So that's going to be equal to the square root of 1 minus, and cosine of 150 would be rad 3 over 2, wouldn't it? The whole thing's over 2. If I multiply top and bottom by 1/2, I get 1/2 minus rad 3 over 4 with the square root over the whole thing. And of course, that's going to be equal to, if I multiply top and bottom of that by 2, I'm going to get the square root of 2 minus rad 3 over 4. But of course, the square root of 4 is 2, so this is actually equal to the square root of 2 minus rad 3 all over 2. And of course, you could run through that one, and notice that when you run through this one, you will get an answer that looks different, but if you throw them both in your calculator and approximate them, it will give you the same answer. So that might be a good exercise for you to run through this one, because you would have sine of 45 times cosine of 30 plus cosine of 45 times sine of 30, right? And you should be able to get an answer that if you put in the calculator is the same as that. And I think we'll do one more here, or at least get you started on these two. So this one, again, I could double that and do a half angle, or I could do a sum and difference. And if I think about trying to split this up, this would be tangent of, say, 2 pi over 12 plus 3 pi over 12. And I'm hoping that those are friendly angles, and when I reduce them, I find out they indeed are. So that would be pi over 6 plus pi over 4, so that I can throw it in the formula, and that should come out nicely. Same way with this one. I could think of that as half of pi over 6, so that'd be one way to do it, sine of pi over 6 divided by 2, so I'd use a half angle formula. Or I could think of that as sine of, say, 4 pi over 12 minus 3 pi over 12, because that will give me sine of pi over 3 minus pi over 4, and those are both friendly angles. Okay, I think I'll sign off for now.